Hey there guys, and welcome back to another video. So today we're going to be solving two-step and one-step equations. So basically in this video we're going to be running through 4 properties of equality, and then at the very end we're going to be running through order of operations, or in other words PEMDAS. You've probably heard that before. Just so that you know when you're solving two-step equations, you know what order to go in. But for now we're just going to be going over one-step equations and the properties, but later on in this video we will be getting to the two-step, so the chapters will be below if you'd like to skip ahead if you already know this stuff. But let's get on to the first property. So our first property is addition property of equality, and basically it's saying that we are using addition to keep our equations equal, because when we're solving for a variable in an equation, we have our variable right here, which is x, and we're trying to isolate this on its own and get everything else on the other side of the equation so that we know what this equals. So in this case we have x minus 8 equals 2. We have our variable, we have a positive number, and we have what our equation equals. So when we're using the addition property of equality, it's basically saying that we're going to be doing the opposite of subtraction, which is addition. So here we have negative 8, and because of that we're trying to move it to the other side, so we're going to do the opposite. We want it to go to 0. So negative 8 plus 8 is 0, but what we do to one side we have to do to the other, so we have to add 8 to that side. Because these equal 0, we can just cross them out, and we're left with x. Nothing changed with the x, so we just bring it straight down. And then we have 2 plus 8, which is 10. So this is basically us moving that negative 8 to the other side of the equation. And to do that, we have to do the opposite of it, so that we get rid of it on one side, and we kind of teleport it to the other side. But we can't just bring it straight across, because if we had x equals 2 minus 8, you're going to get negative 6, not 10. And we can even check that this is right by plugging our 10 back into here and having 10 minus 8 equals 2. And there you go. That is our first addition property of equality, or using our first property of equality in an equation. And number 2 over here is the same format, just different numbers, and it's the same process. So we have x minus 4 equals 4. We have our variable, which we want it to be by ourselves, so we're going to be getting rid of this negative 4 right here. That was a terrible arrow. This negative 4 right here. And to do that, we're going to do what we did before, where we add the opposite to both sides. So just like that, we have x, that stays the same just like before. We have our negative 4 plus 4, which is 0, so those go away. And we have equals, equal sign doesn't change, so we just bring that straight down. 4 plus 4, which is 8. And that will be our answer. And again, if you just brought your negative 4 back over, you get x equals 0, but that doesn't make sense. And we'll even check our answer again. 8 minus 4 equals 4. That checks out. So we know this is correct, and basically when you're doing addition of property of equality, this is all you're doing, is you're going to isolate your variable and bring your negative numbers to the other side by using addition. So basically that's all for this property, and let's get on to our next one. So our next property is subtraction property of equality. I actually need to fix this really quick. My apologies. That should not be negative. Okay, so basically we're going to be doing the subtraction property of equality, and this states the same thing as the addition property of equality, except instead of doing addition like we were before, now we are doing subtraction. So again, we have our variable, which we want to isolate, so we're not going to touch that. We want to keep it on this side, but everything else, meaning this plus 8, we want to move to this side. So that's what we're going to be doing. We have plus 8 opposite of addition is subtraction. So we subtract 8 from both sides. Again, our variable doesn't change, so we keep that. Positive 8 minus 8. That leaves you with 0, so it cancels out. We don't touch that, it's gone. And we have our equal sign, which we bring down. And now we're working on the other side of the equal sign, where we have 3 minus 8. 3 minus 8 is negative 5. So there you go. That's your answer. And if we, again, plug it back in, negative 5 plus 8 equals 3. And that right there is how we're going to be solving our one-step equation using the subtraction property of equality. It's pretty simple, pretty much the same thing as addition. If we hop over to our second equation over here, it's in a little bit of a different format, but it's the same thing. We have a positive 12 plus a variable equals 34. And again, we want to keep this by itself, this x right here. We want to keep that by itself. So we need to get rid of whatever else is left, which is this 12. We know it's positive because there's that invisible positive sign right there. As long as it's not negative, you know it's positive. So the opposite of positive is negative. So we subtract 12, but we make sure to do it to both sides, or else our equation is going to be imbalanced and we're going to get a completely different answer. So then we have positive 12 minus 12. It equals 0, so that cancels out. Our x stays the same, so we bring that down. Same with our equal sign. And then we have 34 minus 12. And that equals 22. So that right there is your answer. And we can plug it back in by having our 12 plus 22 equals 34. And that right there is our equation. And it checks out. Both of them. So there you go. That is this subtraction property of equality, and it's really similar to addition. They pretty much go hand in hand. But our next property is going to be changing just a tad bit. Okay, so our next property of equality is going to be the multiplication property of equality. So this one obviously looks a little different, but it's probably just quite as easy. It just takes just a tad more thought process to it. So obviously we have a different format, but here we see x over 4, or we see a fraction that says x divided by 4 equals 6. So basically, like we were doing in addition and subtraction, we're doing the opposite of. The opposite of a subtraction was addition. The opposite of addition was subtraction. Same thing here. The opposite of multiplication, or the opposite of division in this case, would be multiplication. And whenever we see a fraction, you need to think this is division. Because, yes, it's a fraction, but it's also division. Like when we're looking at this, x divided by 4 equals 6 is the same thing. You're having your x, and you're trying to split it among 4 parts. And you're trying to equal 6. It's the same exact thing. Even your division symbol, it has that little fraction bar. And it even has dots where your numbers would go. So you're basically saying the same thing there. So whenever you see a fraction, think division. What's the opposite of division? Multiplication. Now to figure out what we need to multiply by is the difficult part. It's not that difficult, it's just not right there in front of your face. So basically, as we know, variables, they have a 1 in front of them. And to get this denominator to cancel out, because that's our goal here. We want our denominator to cancel out. We want it to be gone. We want it to go bye-bye, right? So we're trying to get rid of that. And to do that, we need our denominator to kind of be able to equal our numerator. So we can kind of just cancel that out and be left with one term. So to do this, we kind of need this 1 right here to equal 4. In this case, we need it to equal 4. So, what times 1 divided by 4 would equal 4. Or equal 1. My apologies. Equal 1. Well, if we were to multiply this by 4, so we have 4 times 1 over 4. What would that equal? Let's write it out. 4 over 1 times 1 over 4. Well, that would equal 4 over 4. We can even plug our x in here just so you can see. I don't want you to get confused. So that's what this is. This is what we're seeing right up here on this side of the equation. This right here, that's all that is exactly what I wrote down here. And because we have a 4 divided by 4, that's just 1. We can just cross that out. And we're left with just x. But we can't forget about this side of the equation. And like I said before, what you do to one side, you have to do to the other. So let's multiply this by 4. So we know this side over here, where I'm making my little dots, this side equals x. We already established that. We already were able to get rid of that fraction and make it x. This side we still have to take care of though. We have 6 times 4. Well, that's simple. 6 times 4 is 24. And that's your answer right there, 24. And if we were to even substitute it back in where we had x over, 4 equals 6. And what does our x equal? 24. 24 over 4. Does that equal 6? 24 divided by 4. It does equal 6, so that checks out. And that's basically how you would solve it. Now, I'm going to show you over here what you would do if you had a denominator that was a variable. This gets a little confusing, so I will show more examples in the future. And I don't even believe you focus on this too much in algebra, or especially pre-algebra, maybe even algebra. But for this, we have to do the same thing. We're just trying to get rid of this fraction, right? So here, we're going to write this, we're all simply, to just put it really easily, we're just going to multiply by a variable. Because if we multiply both sides by x, right? Let's think of it as multiplying by x over 1, just so it's easier. Let's multiply by x by 1, or over 1. Okay, equals 12. Now we have to multiply this side by x as well, because what we do to one side, we do to the other. So now let's multiply across. We have x times 3 equals 3x. And then we have 1 times x just equals x. Now, what do we see that we can do? Because over here, we had 4x over 4, and we were able to cross out our 4's. Well, now what is our fraction share in common? An x. We can get rid of it. So now we have 3 equals 12x. Now what do? We divide both sides by x. Now this here is a two-step equation, because you're doing all this multiplying and dividing. This was just the subtraction property of equality, this left side. But because this right side, you are left with a variable after you already did your first property of equality, now you are doing what we would call the division property of equality, which I'll actually be getting into in just a second. But there you go, you already got a glimpse of it, where we have our number, we divide by the same thing to get our variable by itself, and then there we go. We have x equals, I didn't even put what x equals. X equals 1/4. Now I want to go back up here and plug this in really quick. So our equation was right here, and we had, oh, that's not right. We had 3 over x equals 12. Now, just really quick, I want to convert our 1/4 to decimal, which is 0.25, just because it'll be a lot easier to work with that than 1/4, because if we have 1/4, then we have a compound fraction, and compound fractions can get a little iffy when you're working with them. So just to make it easier, let's just write it as that. And then 12. If you pull out a calculator and you do 3 divided by 0.25, you do indeed get 12. And there you go. That's your answer. So I did kind of go ahead and I did do the division property of equality, but I will be getting into that right now. So if you're confused about it, just wait just a little, like a tad bit longer. I will be explaining it right now. So as I just said a second ago, we're going to be working on our division property of equality, which is very, very similar to multiplication. It's kind of like division and subtraction, how they go in hand, or addition and subtraction, how they go in hand. We have our multiplication and division that go hand in hand. So, as we are looking at here, this format is really similar to what we just experienced, where we had 3 equals 12x. That's what we had just a second ago in our last problem. So here, we're doing the same thing, where we have our variable with the coefficient, and we have what it equals. So to get our variable right here by itself, we have a 2 that's multiplying this variable. It's basically saying we have 2 variables that are multiplying by each other, but we don't want that. We want to get rid of this 2. So to do that, we basically are breaking this multiplication bond by division. We're dividing by 2. And what we do to this side, we have to do to this side. So we're dividing both sides by 2. Again, look a little familiar with our fraction from before, where we have 2 terms that equal each other. So we can just cross them out. They're not there anymore. And look at that. We're left with x equals 6 divided by 2, which is 3. And there you go. If you plug it back in right here, where 3 goes back into x, we have 2 times 3 equals 6, which checks out. And that's literally all it is. It is practically the same thing as before with division, except, or the same thing before with multiplication, except this time we're dividing. And over here, we're doing the same thing, except this number is negative. So we take this number, divide by -6, and that leaves us with our 6's on this side canceling out. Leaves us with x, so we bring that down. We have our equal sign. We have 24 divided by -6, which happens to be -4, because you have a positive number. Positive divided by a negative equals negative. And boom, that's your answer. And if we bring it back here, back into our equation, we have -6 times -4. Oh, this should be, yeah, that's right. So -6 times -4. Negative times negative gives us a positive. 24 equals 24. Boom. It checks out. So there you go. That's all the 4 properties of equality. And now I'm going to try and quickly run through just a couple of examples, because I don't want this video to be too long. I'm pretty sure we're already pushing like 19 minutes. So I'm going to do PEMDAS, and I'm going to do a couple examples, and then that should be all for this video. I almost forgot about this one. This one isn't necessarily a property of equality. To my knowledge, I don't believe it is. Yeah, I'm not sure. I don't believe that it's a property of equality. If it is, I don't have the name right now. I'm sorry. But basically, when we have our exponents, to cancel them out, it's like you use your square root. So basically, if we have x to the second, it kind of goes hand in hand with the square root. So squares and square roots are kind of like the opposites, kind of like multiplication and division and addition and subtraction. So as we see right here, we have a x squared. So it's basically saying x times x, okay? Which means if we square both sides, our square and our square root just disappear, like they're gone. They cancel each other out. And then we the square root of 64, if you use your calculator, it will tell you that it's 8. And if you're in algebra, I would use positive or negative, because you have to try and get in the habit of knowing that we could also plug negative 8 into this equation, just as we could positive 8, and they'll both equal 64. So having that positive negative sign is really important in algebra. And then if we move over to our equation over here, it's the same thing with cube roots. If we have a cube root and we have an x to the third power, they cancel out. And then we can do the same thing on this side with our cube root, and we get x equals positive or negative 6, I believe. Let's just make sure. 6 times 6 times 6 is 216. So there we go. We have our positive negative 6 again. If we had, not squared, negative 6 cubed and positive 6 cubed, we could get 216 out of both of them. So remember, if you're in algebra, use that positive negative sign. If you're in pre-algebra, I do not believe it matters. So basically, that's our last little thing about properties. Now let's get on to the PEMDAS, and then hopefully I'll have enough time to do some examples for you. Okay, so basically this is order of operations. And this is basically, this tells you that when you're solving an equation, it tells you what to solve first, because you have to go in a specific order, or else you're going to get all mixed up and you're gonna get the wrong answer. So this is, I believe they're called acronyms. But basically every letter in this word stands for another word. So we have our P. This stands for parentheses. So whenever you're solving an equation, the first thing you're going to do is parentheses. So in this case, boom, right there. We have parentheses. So everything else stays the same, but we solve our parentheses. Okay? I'm actually going to, this is a negative sign, or not a negative, a multiplication sign, so I'm just going to change it so it doesn't look confusing. Right? So our first thing to do is parentheses. First thing. Next, we look for exponents, which is the E in PEMDAS. And right here, we have an exponent, right there. So 10 divided by 5 times 4 plus 25 plus 6 minus 9. You're basically just doing one step at a time, going down, going down. So right here, our M is multiplication. But really quickly, you can see I have MD underlined and AS underlined. This D stands for division. These two are interchangeable. Whenever you get to the M and the D, you just solve from left to right. You don't go in a specific order. Like, you don't do multiplication first, you go through, pick at all the multiplication, and then do division. You solve from left to right when you do multiplication division. So here, you can see we have division, we have multiplication, and that's it for our M and D, for multiplication and division. Even though division is second in our word, right, we are going to do it first in this equation, because we're just solving from left to right. So 10 divided by 5 is 2, and then we bring down our multiply by 4. 2 times 4, 8. And then we bring the rest down, and it's the same thing with this AS. Addition, subtraction. They're interchangeable. You could do your subtraction first or your addition first. It depends on whatever falls to the left. So here we have 8 plus 25, which is 34. Or not 34, 33. My apologies. 33. And then we add our 6, which is 39. So we have 39, we bring down our subtraction, and we get 30. So this equation right here, up here, equals 30. And even if we went through and did this how we weren't supposed to, and let's say we did 5 times 4, and we get 20, 10 divided by 20, what is that? That's 1/2. 1/2 plus 25 plus 6 minus 9, that's not going to give you 30. So this is why you have to go in order from left to right, and you also have to go in the order of PEMDAS. But remember that these two are interchangeable with each other. The two groups. So you could have PEMDAS, you could have PEMDAS, you could have PEMDAS, you could have PEMDA. Like, they're interchangeable, but don't go and try and change your M and your S or your D and your A. They're groups. It's P. Oh, that was a terrible P. It's P, then E, right? And then you have your M, D. Those go together. And then your A and S. Those go together. So P, E, M, D, A, S. Don't go around trying to flip it all together. It goes in that order. But it's pretty simple once you get the hang of it. You won't even have to think about it. You just solve, solve, solve. But that's basically it for the PEMDAS and the order of operations, inequalities, properties, stuff like that. So basically I'm going to get into probably 1 or 2 examples just really quick so that this video is not too long. Okay, so really quickly, let's get into this just really quick. Our first equation is 5x plus 8 equals 23. So first off, remember PEMDAS. We are going to be starting with parentheses. There's no parentheses. Exponents, no exponents. Multiplication, there is multiplication. But whenever you are solving an equation, you want to isolate your variable first. So what I just did there is an example of what not to do. Don't go into your equation and go PEMDAS, parentheses, exponents, multiply. Don't do that. You want to isolate your variable, and PEMDAS will be for if you have the side without, or the side, like, let's solve this really quick. So we want to isolate our variable, right? We do that to both sides. We get 15, 5x. These cancel out. 23 minus 8, 15. So we're left with 5x equals 15. This side right here, if there was anything on that side, that's where we'd use PEMDAS to try and simplify. We would not be using it in this equation because of the fact that we want to get our variable by itself. Because if we went by PEMDAS, we'd be dividing by 5, like right at the beginning, and that's not what we want to do. Okay, so there we go. We have our 5x equals 15, and then division property of equality, x equals 3. And if we plug this back in, we have 5 times 3 plus 8. 5 times 3 is 15, plus 8 is 23. So this checks out. Now if we go to this one over here, same thing. Don't go, oh, parentheses, exponents, multiply, divide. Oh, this is multiplication. Let's divide. 6. 6. You're not going to get the right answer. Okay? So don't do that. You want to start by isolating your variable by, getting everything on that side that's not the variable to the other side. So our negative 11, opposite, plus 11. Do that to both sides. 13 plus 11. Let's simplify. 6a, bring it down. These cancel out, our 11s. And we have 24. Division property of equality. Same thing as over here, where we divide by this number that's right here so that we can get this variable by itself. So when we divide both sides by 6, keeping it equal, we get a equals 4. And if we plug it back in up here, we have 6 times 4 is 24. Minus 11, that is 13. So there you go. That's pretty much all you need to know about these properties. I'm going to try and squeeze in just 2 more examples really quickly so that I can finish off the video for you guys so you guys are not here forever. Okay, so here are our last 2 examples of the video. And again, If you go into this thinking PEMDAS, don't. You're going to get it wrong. You want to isolate your variable. That's your goal here. So we have our positive 8. We don't want that. We want to do the opposite. But remember, we have to keep it equal. So we do both sides. And this will give us negative 3. These will cancel out. And we bring our variable down, which is k over 6 equals negative 3. If you remember back to our multiplication property of equality, we want this fraction to go away. So we kind of want this 6 down here, up here. So to do that, we multiply by 6. And that'll give us 6k over 6 equals negative 3. Okay? And again, you see that? The 6, they share it. Like they share a number, basically. They're the same, they equal each other. They cancel out. In a fraction, they'll cancel out. So then we are left with k. But don't forget, like if we go back up here, let's add this in. We need to do the same to both sides. So negative 3 times 6 equals negative 18. And if we plug it back in up here, I'm going to do it. Well, I don't want to have enough. I'm not going to have enough space for this, but if we have negative 18 where this k is right here, divide that by 6, that's negative 3. Negative 3 plus 8 equals 5. So our answer checks out. And over here, this is a pretty simple equation. So we have our 2 right here that we want to get rid of because we want this variable to be by itself. So we do the opposite of positive 2, which is subtraction, do to both sides to keep it equal. That cancels out. We have 9g equals 18. And then this is where we go back to our division property of equality. And we divide both sides by 9. And we get g equals 2. We can plug it back into this g back up here, right there. 9 times 2 is 18, plus 2 equals 20. So this checks out. Oh, my apologies. This checks out. And it is basically the same thing. So, basically that is all for this video. And that's pretty much all the properties you need to know. So, if you need any more help on this, if you think I went a little too fast, or if you just want me to do some more examples, I can upload another video, or just a quick TikTok even, to show you guys what to do. So, hope you guys enjoyed this video. Thank you for watching. If you did, I hope this helped you, and I hope you continue to keep watching my videos, subscribe, turn on notifications so you know when I post, and that's pretty much it. And remember, math is delicious. Peace.